In this lesson, you will learn how to find the greatest common factor. First, let's look at some definitions. And we'll start with factors. Factors are numbers that divide evenly into a number. So if I take the number 2, 2's factors are only the numbers 1 and 2. Whereas a number like 12, 12's factors are 1 and 12, 2 and 6, and 3 and 4. A number like 25 has factors of 1 and 25 and 5. The greatest common factor is the greatest factor that two or more numbers have in common. So if I take the numbers 12 and 18, when you're finding the greatest common factor, I'm just going to list the factors just as I did earlier. 12 has factors of 1 and 12, 2 and 6, and 3 and 4. And 18 has factors of 1 and 18, 2 and 9, and 3 and 6. So if I look at these two lists of numbers, I notice that 6 is the largest number that both lists have in common. So you would say that the greatest common factor is equal to 6. Two numbers are relatively prime if their greatest common factor is 1. So I'll still use the number 12, but this time paired with the number 25. And if I list the factors of 12 again, we have 1 and 12, 2 and 6, 3 and 4. And for 25, 1 and 25 and then 5. The largest number, and actually only number that they have in common, is 1. So two numbers are relatively prime when their greatest common factor is 1. So now we'll start with the examples, and we're asked to find the greatest common factor of 12 and 33. So the same process that we were just doing earlier. I always list factors in pairs. I find it easier this way so that you don't forget any. And the only factors for 33 are 1 and 33 and 3 and 11. And I look for the largest number that the two lists have in common, which is 3. So my greatest common factor is 3. For number 2, 54 and 60. So for 54, we have 1 and 54, 2 and 27, 3 and 18, and 6 and 9. For 60, this list is a little bit longer. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So I'm just looking for two numbers that multiply to 60, and I just go in order until I get to a repeat, 6 and 10, and the largest number on this list is the number 6. So you always want the largest number when you're finding the greatest common factor. So for example 3, 72 and 224, we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. And for 224, we have 1 and 224, 2 and 112, 4 and 56, 7 and 32, 8 and 28, and 14 and 16. And the largest number on this list is the number 8. Now when you have three numbers, the process is the same, we just have to make three lists. So of course, the larger the number, often the list is longer, but not always. So we always start with 1 and the number itself, and then since 48 is even, we go right to 2, and then 48 divided by 3 is 16. 4 times 12 is 48. We know 5 won't work because the number ends in 8, and that brings us right to 6. And 7 goes into 49, and then when we get to 8, 8 is on the list, and that's how we know we're finished. So that's the advantage to writing them in pairs. So for 92, we have 1 and 92. 92 is even, so when you divide 92 by 2, you get 46. 3 does not divide into 92. And then the last pair is 4 and 23. And for 120, we go through the same process. And now we look for the largest number that the three lists have in common, and the largest number is only 4. So the greatest common factor is 4. So now for number 5, what is different about the rest of these examples is that now we have variables. These are each monomials. Remember, a monomial is a term where you may have letters and numbers together, but they're all attached by multiplication. So when you're finding the greatest common factor for monomials, the number part is the same. We're still taking 54 and 60 and listing its factors. And these are actually the same numbers from number 2, example 2 that we did earlier. And we'll just list them out again, but we know that the greatest common factor will be 6. So the largest number they have in common is 6. So the greatest common factor so far is 6, but then when I look at the two terms, one has an x squared and one has an x to the third. When you're finding the greatest common factor with variables, you want the lower of the two powers. So this one has a power of 2, the second one has a power of 3, the lower of the two powers is 2, so it's 6x squared. So for number 6, we start by listing the factors of 16 and 36, same way as we've been doing this earlier. 1 times 16, 2 times 8, and 4 times 4. And for 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And so far, the largest number that we have on the two lists is the number 4. So it doesn't matter which 4 you circle on the 16 side. So far we have 4 is the greatest common factor. But now I look at the letters, and if I start with the x's, we have an x to the first and an x squared. Remember, for greatest common factor, we want the lower of the two powers, which is x, or you can even write x to the first. For the y's, one of the y's is y to the third, and one of them is y to the fourth. The lower of the two powers is y to the third. So we can say that the greatest common factor is 4x to the first, or just x, y to the third. For number 7, 8m and 28. So I start by listing the factors of 8 and 28. And the largest number that the two lists have in common is the number 4. So I start with greatest common factor is equal to 4. Now the problem with this one, or the difference between this one and the last two examples we did, is that only one of the terms has a variable. The 28 does not have a variable. So since only one of the terms has the letter m, you cannot include it in the greatest common factor. Both terms have to have that letter when you take the lower of the two powers. If they don't, then you don't include it in the greatest common factor. So therefore this one only has a greatest common factor of 4. You don't include the m because the 28 does not have an m attached to it. And for the last example, mn squared, m cubed n, and mn cubed. So I'm just going to write these out. I don't have to make a list for this one because we don't have any numbers in front other than coefficients of 1. So all three of these terms have the letter m. And the first one has a power of 1, the second one a power of 3, and the third one a power of 1. So since they all have the letter m, we take the lowest of all three powers, which is just 1. Two of them happen to have a power of 1. And then for the n's, we have an n squared, an n to the first, and an n to the third. The lowest of all three powers is n to the first. So the greatest common factor is mn.